everyone, and welcome to AI Tech for Growth channel. AI is everywhere, but what do terms like machine learning, deep learning, and foundation models actually mean? And how do they connect to AI? Lisa hears these words all the time, but they feel vague and confusing. If you feel the same way, you're not alone. By the end of this video, you'll have a crystal clear understanding of AI's key technologies. So, let's break down these key AI technology terms one by one, and more importantly, see how they all connect using easy-to-grasp examples. Imagine Amazon as a dynamic business empire where every operation is optimized to serve customers and drive growth. Each AI technology functions like a specialized department in this corporation, working together seamlessly to achieve success. AI. Artificial intelligence AI acts as Amazon's executive team, orchestrating strategies across the organization. While it doesn't directly handle every task, it ensures that all divisions like machine learning and deep learning collaborate effectively to enhance customer satisfaction and operational efficiency. Example: just as a CEO oversees company strategy, Amazon's AI optimizes logistics, personalizes shopping experiences, and improves customer service. Machine learning ML. Let's explore machine learning and deep learning DL. Lisa watched videos and read materials, but found the distinction between them quite vague. Does that resonate with you? Let's clarify using the example of Amazon's marketing department, which utilizes ML and DL to analyze vast amounts of customer data for effective marketing strategies. Imagine the general marketing department broadly using ML, while the strategy team within it exclusively applies DL. Often, people say ML uses structured and labeled data, but that's not entirely true. ML actually works with structured and unstructured data, as well as labeled and unlabeled data, and it can even work without data. Why, you ask? Because ML has 4 distinct learning approaches. Let's take a look at these approaches and revisit our example of the general marketing department to illustrate how ML functions. 1. Supervised learning uses labeled data where inputs are mapped to known outputs. Here is the example in marketing. Predictive analytics. Predicting customer churn or future purchases typically uses historical labeled data, such as past customer behavior, and whether they churned or not to train a model to make predictions. 2. Unsupervised learning uses unlabeled data to discover patterns and relationships. Customer segmentation and targeting. Clustering customers into segments often uses unsupervised learning techniques to discover natural groupings based on customer attributes without predefined labels. 3. Semi-supervised learning combines labeled and unlabeled data. Predictive analytics. When historical data has only partial labels, semi-supervised learning can enhance the predictive model by leveraging both labeled and unlabeled data. 4. Reinforcement learning doesn't primarily rely on labeled or unlabeled data, but instead learns through feedback rewards/penalties from interactions with an environment. Recommendation systems. ML-powered recommendation engines can use reinforcement learning to optimize recommendations by learning from user feedback rewards or penalties over time. Note that structured data including tables, databases, and unstructured data including text, images, audio, video both can be labeled or stay unlabeled, or can be partially labeled. Deep learning. Now let's move on to deep learning, which can be very confusing. Deep learning is a subset of machine learning, and it can be applied to supervised, unsupervised, semi-supervised, and reinforcement learning scenarios across all types of data. What sets deep learning apart from machine learning? As explained by IBM master inventor Martin Keen, the primary distinction between machine learning and deep learning DL lies in the number of layers in their neural network architectures. Key difference: number of neural network layers. Machine learning, traditional ML models often use simpler architectures, which may include shallow neural networks with 1 or 2 layers, or no neural networks at all. Deep learning. DL models use deep neural networks, which are characterized by having 3 or more layers, including input, hidden, and output layers. The depth refers to the number of hidden layers in the network. This depth enables DL models to automatically extract complex features and patterns from a huge amount of raw data. For example, the marketing strategy team mentioned earlier leverages deep learning to handle larger data sets like millions of records and tackle more complex marketing tasks with high accuracy. Examples of the marketing strategy team: better recommendations. Deep learning enhances recommendation systems by predicting customer preferences with higher accuracy, increasing engagement by up to 41% compared to ML-based systems. Predicting consumer behavior. Deep learning analyzes deeper behavioral patterns to forecast demand for products, optimize inventory management, and improve supply chain efficiency. However, DL models typically require significant computing power, especially for training. This can translate to higher expenses for hardware, such as GPUs and cloud services. Therefore, companies need to evaluate the potential ROI return on investment against these costs when deciding between ML and DL solutions. Foundation models. Foundation models exist within deep learning as versatile AI architectures that fuel a wide range of applications. Much like expert marketing strategists trained on vast datasets, these models can be fine-tuned for specific needs across industries, making them foundational in driving AI innovation. Key examples of foundation models include large language models LLMs, such as GPT-4, which excels at answering questions, generating text, and summarizing information. Vision models. These models interpret and generate images, such as OpenAI Clip or Stable Diffusion, used for tasks like image captioning and content creation. Audio models. These generate human-like speech or creative content, such as composing music or synthesizing realistic voice outputs. Large language models LLMs. As a subset of foundation models, large language models provide the fundamental capabilities that power natural language processing NLP applications, making them invaluable for human-like interactions. These advanced AI algorithms are designed to process, understand, and generate human language with remarkable accuracy. As real-world application, Amazon integrates LLMs into its customer service. Alexa provides 24/7 voice assistance for shopping or managing smart home devices. LLMs generate personalized email responses at scale for customer support. Generative AI. While machine learning, deep learning, and foundation models analyze data and make predictions, generative AI takes it a step further by creating entirely new content, text, images, audio, music, video, or even code. It's transforming industries by boosting creativity and efficiency. Applications of generative AI in marketing. Content creation. Automatically generate blog posts, articles, social media content, and ad copy, saving time and resources. Chatbots and virtual assistants. Improve customer interaction by providing personalized and contextually relevant responses. Product design. Generate new product ideas and designs, enabling faster innovation and customization. All right, let's put everything together. AI, the strategic leader, orchestrating technology for optimized efficiency. Machine learning, the analytical backbone, identifying patterns and making predictions. Deep learning leverages multi-layered neural networks to process vast datasets and perform predictive analytics. Foundation models, adaptable AI frameworks powering text, image, and audio applications. LLMs. LLMs are designed to process, understand, and generate human language. Generative AI, a cutting-edge creative tool that produces new content in various forms and is increasingly used to assist people and industries. Hopefully, this breakdown made everything much clearer. But now, I want to hear from you. Before this video, which AI term confused you the most? Let me know in the comments. Thanks for watching, and I'll see you in the next video about the metaverse. Lisa is excited for the next step. Are you too? Let's dive in together.